Hello, can
Hello, can hear
yeah,
you.
I Cynthia. You were saying something?
Yes, I wanted to ask something. I was trying to get more time because I'm having an exam from Monday, not from Monday, from Tuesday, and I
Okay.
needed more time to complete the assignment. I don't know if that's possible.
Yes, no problem. No problem. So have you been able to, get started with it?
Yes, I've already submitted the first one.
Great, 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 great,
Yeah.
great. So I'm going to go through that. I'm going to go through that. Great. So we would literally just continue and yeah. So we stopped yesterday at the crowdfunding that we were implementing, and we will basically just continue from there now. So I'll share my screen, and then I would open the crowdfunding contract. So yesterday we kept having this error that had to do with our mapping. So interestingly, immediately we got off the call, I saw the problem, where the problem came from. And it made me remember what I was saying and explaining in our previous classes, that it's so easy for us to make mistakes. It's so easy for us to have errors, especially when we don't follow certain instructions. Now, if you can remember, I've always mentioned that everything we are using, whether it is vector, string, address, everything we are using should come from where? The Soroban SDK. Now, when I declared this mapping here, I did not import this map from where? From the Soroban SDK. Rather, the map automatically just came from what? The standard library iterate, and it got mapping from there. And so the mapping from here is completely different from what? The mapping from the Rust what? From the Soroban SDK. And so for that reason, we had that error. Just because where we are importing mapping from is different from where we should have imported it from. And like we said, no importation from raw standard library. So we definitely would not want to use it. So I would remove it. If I remove it and I come here and I add map, yeah, automatically all of our errors is gone. Can you see? All of the places we used map and all of that, all the error is what? All the error is gone because the map we have here now is the map coming from where? The Rust standard library. And here it is. Notice that when we opened the map the other time, that map did not implement the try from val. And so I was asking, at what point did we not implement the try from val and all of that? But this one actually implements both the into val and the try from val. This is actually kind of equivalent to talking about the contract type. So doing this and implementing the try from and into val for a particular data type, it's just like doing the contract type. It's using this contract type trait. So that's that for that. And that's with that, we are able to, solve the bug issue that we had to do with um that had to do with the code. So the next thing we are going to do today is to implement refund. So today we are going to implement refund, get campaign details, is goal reached, and get all campaigns. I really hope we are able to implement all of this because we really have so much to do. So let's start with the implementation of refund. So to implement that refund is basically a situation whereby the goal is not reached for the campaign. That's the campaign you are trying to create, the goal is not reached. And so for that reason, you did what? You're trying to implement what? What will help us to reach the campaign. In this case, we're going to do what? Contributor. We're going to start with the authorization. Nobody can call it unless the contributor, the person that contributed. So if you contributed, you can call it. Then we're going to check. We are going to check for the campaign. Which of the campaign did it contribute to? So let's get that campaign out. We are going to mutate that campaign. You know, why are we mutating it? Because obviously we want to deduct the person, whatever he contributed, we want to deduct it from the total contribution because we want to transfer that money back to him. So we are going to easily just use our method that we have created, that get campaign method, that helper function. So we are just going to use it, passing the ID and the environment. We already have campaign ID here, so we are going to pass in campaign ID. And what else do we need? You're going to use .expect. You remember what .expect does? Returns an error if not found. So if the campaign is not found, it should return an error campaign not found. Then the next thing is we want to assert. First of all, we want to ensure that the deadline is not over. The deadline. So we want to check. I think we have a check deadline method. So you see how easy my code is, especially when I'm using helper functions. I just keep repeating it over and over. We're going to check deadline. So we're going to say campaign dot deadline. So we pass in the campaign deadline and check the deadline. We're going to assert that it's still on. If it's not on, what should we say? You can withdraw. But if it is on, we tell the person campaign is still what? It's still active. Just like that. Now, the next thing we also want to check is we want to ensure that the moment you request for refund, at that particular time, the goal is not reached and the time is not reached. We have checked that the time is reached, that is, the campaign is over and the goal for the campaign is not reached. So we also want to check to ensure that that goal that was agreed to be reached was not reached. If not, this person can withdraw the money. So we are going to assert that. We're going to assert that what? The campaign dot raised, that's the amount raised, is less than what? The campaign goal. And if not so, we're going to say campaign goal not reached. No, we say campaign goal was reached. So no refunds available. And yeah. So now that we have checked both the time that the campaign is no longer active and that the goal was not reached. So the next thing we are going to do now is we are going to get the contribution. Do we have a get contribution method? Okay, good. We have a get contribution method that returns the mapping. Good, good. You see why upper function is good. So we're going to get the person's contribution. So we're going to get the contributions first, and we want to perform some arithmetic on the contribution. Contributions. So we use get contributions. It's going to return a mapping. Yes. A mapping of address and what I want to it. Then we're going to say let amount equals what? Contributions contributions dot get, and we're going to pass in the contributor dot clone. We're going to clone it, and then we're going to get the person, how much he contributed. Then we do dot expect. Now, if the person did not contribute anything, the person can't withdraw anything. We say no contribution. So we say no contribution available. Next, the next thing we are going to do is, if the person is able to get his contribution literally, we are then going to use this amount. This amount is what we are going to use to send the person his money. So we're going to say token client. So we're going to create the token client. Token client. Import token, and we're going to get the client, and then new, and then we're going to pass in the address of the token. I think we already have a method that returns the accepted token address on this contract for the campaign. So we're going to pass in get token, and it should give us that. The next up is we are then going to what are we going to do next? We're going to transfer the money to the person. So we say token client dot transfer. From where? From the contract. So it's going to be from the contract. So it's going to be e dot what? Dot contract address. E dot current contract address to who? To the contributor. And how much? The amount he contributed here. So the next thing we are now going to do is what? We're going to remove the contributor. Contributions dot what? Dot remove who? The contributor. So now we've removed the contributor. So let's first of all remove the contributor before we send the money. So we've removed the contributor, and then the next thing we are going to do is we're going to put back the contributions back. And so we are going to pass in the campaign ID and then the contributions. And then we pass it in here. So what error? Campaign ID. Okay. Borrow of moved value. So let's look at contributor. Let's look at where did we use contributor. Contributor. Okay, let's look at this. Contributor. Here is the contributor. Okay, can we do dot copy? Okay, should we do this? So where was it gotten? Where was it used? Borrow of moved value. Value moved on line 170. Oh, oh, line 170. Contributor. Yeah. So let's do this dot clone here. Let's do it here. Let's remove this. And then we are good to go. Let me see if for this address we can use Oh, it only implements the clone. It doesn't implement the copy. So let's just clone it there. So we pass it in like that. We are good to go. We are good to go. Okay. So any questions on this refund? Any questions on this refund implementation? Questions? Questions? Okay. Seeing that there's no question, we'll literally just progress. Uh, so like I mentioned, we've solved the issue we had for the mapping. We were not importing from the Soroban SDK. We were literally importing from ITA using the standard Rust library map instead of the map coming from the Soroban SDK. So the next one we want to implement now is get campaign details. So for get campaign details, I think we have an helper function. This should not be hard to get campaign details, do we? Get campaign details. So I think we have it. Here we have it. I think we've used it before. See how beautiful it is to have helper functions. So we are just going to call our get campaign details here. Get campaign. It's going to pass in the E, that's the environment, and pass in the ID. And we are good to go. Okay, let's use .expect. Let's expect a message. The message would be campaign not found. Campaign not found. And we are good to go. Okay, so let's check if our final goal is reached. For this one, we are going to get our campaign. We are going to use this get campaign still, since we can access the campaign from this get campaign. Passing in this campaign ID, we can get the campaign, and then we can literally check if the goal has been reached. So we're going to say get campaign. We're going to call it, still pass the campaign ID, and this time we are going to use dot map. Let's use dot map. No, let's use dot map or. So the default, we're going to return it as false. And then for the other one, we're going to use this closure, and this would represent the campaigns. So each of these C is more like, you can think of mapping in JavaScript. So the mapping for arrays in JavaScript, can think of it working the same way here. And so this would represent each of the elements in that array. But in this case, it's different. It's a vector. So we're going to get the element, and so we are going to check if the amount has been, we are going to check it against the goal. So we are going to check the amount raised versus the goal. So we're going to say C dot what dot raised. We're going to check it. If it's greater than or equal to what? C dot goal. So it's either going to be return us a true or a false value. Now, this should return all campaigns. So for this, we're going to say, let's create all the campaigns. All the campaigns. We're going to create a new campaign and just return everything. Vec new. Done. E. And then we're going to call the get campaign. So we're going to say for ID in 1 to whatever amount of campaigns we have. Do we have get campaign count? Okay, we have get campaign count. Let's use to the total amount of campaigns we have, E, and then we're going to what? We're going to push everything inside of this vector. We're going to destructure it by using the if let for the option enum, and we say if let sum and we pass in the campaign. This is the value of the campaign we are destructuring. And then oh, sorry, that's a different code base. Sorry. So, that's if let, and then we put some, and if let some, okay, equal to, then we call the get campaign. So we're going to pass in the get campaign. See how I'm just using all of the helper functions I have created before. Get campaign. It's good to have a helper function so your code is not messy and you don't repeat a lot. I'm going to say campaign dot pushback, campaigns dot pushback, pushback, and then we pass in the campaigns we are pushing into it. Campaigns. So we are passing in all of these campaigns inside it. And then at this point, we will then return what? Campaign. Oh, I'm not spelling this right. So at this point, we will return this. And then we are all good to go. We are set. So officially, we've completed our smart contract. This is literally the first assignment. Look at how beautiful our code is. We implemented the initializer that creates campaign, that contributes for a person to contribute, the claim funds, the refund, and next we implemented the get campaign details. So this is just excellent that we did. This is really excellent that we did. So any questions, please, based on this that we have done? Any question? You can use the raise hand button if you have any question. Okay, I think someone. The test, this person asks, is the test part of the code important or just deploy without it? As a developer, it's not wise to deploy your code without a proper test. In fact, you'll be surprised to know that there are some code base where the test is more than the main code itself. You cannot just deploy bug for people to use. It's not ideal for a developer, no matter what you are writing, no matter what code you are writing, even if you are writing front end, there are tests for your front end. So you can't just write, and now you are talking of a financial smart contract. You have to write tests. Even if you want to audit your contract, auditors will ask you for the test of the contract. So it's important you test your code to ensure that what you wrote is working. It's not just working, it's working fine, the way you want it to work. So that's why it's important to write tests. Any other question? Okay. If there are no questions, then let's go to writing our test. I really like splitting my screen a lot. In fact, that's why from this code, you can see this is one code I'm working on. Although this is Solidity, not Rust. It's always, it's always me putting splitting my screens so I can see everything. So here was our format test. The test, this is, we can't even call it format. This was the test that came with the contract when we first initialized this project. This was the test that came with it. This was the test that came with it. So let's start. So the first things we want to do, we want to import certain things. We have the vector, we have env, we have string. We want to import some other things too. Some other things like our test suits, our test utils. Inside of our test utils, we have things like address, and we say address as this. And then we also have ledger. So ledger will give us access to all of the places where we are using the timestamp, something like this. Ledger will give us access to that. Okay. Mm, Also, do we need the symbol shots? Let's just add symbol shots. Did we use it anywhere though? I'm not sure we used it anywhere. Did we? Okay. Let's just leave it. Let's just leave it. Okay. So obviously, what we are doing first, we are removing everything here. In fact, let's remove everything here. Let's remove everything. Let's start from scratch. So for this, there are certain things we want to test. First of all, we want to test from the very beginning. Here are the things. Let's write a list of the things we want to test for this contract. Let's think. For our test, we want to definitely test the initialize. Obviously, looking at this first function, we want to test the initialize. Then we want to test if create campaign was successful. Then next, we want to test if the create campaign had invalid goal. Let's test for invalid goal. Then the next thing we want to test for is let's test to see when a contribution is successful. Test if contribution. Notice what I'm doing. What I'm doing is that I'm writing out the test cases that I want to test, looking at my contract. Now, the thing is that you might not have all the test cases in your head yet, but it's important that at least you start with writing out those that you can remember for now, those that you think are very important for now. So you start by writing all of those ones down. Then afterwards, you can now begin to add more as time goes on. So we are going to check to test if the contribution was successful. If not, we're also going to check for it. We're going to also write a test for what? For the contribution after the deadline. Test to contribute after deadline. Now, remember that we said that a person cannot contribute again after deadline. Let's see. Did you add that? Hmm. Did we add that? Let's look at it. This is the contribute function. I don't think we add that. So should we add if to avoid the person from contributing after the whole thing has ended? Hmm. We didn't think of that while we were writing. Because we could easily come here and just say something like assert that we could, where is it? In fact, we've done it somewhere here. They've done it somewhere here. We could just come here and do this too. We could just do this. We can just check for deadline, but should we not, now this is all about decision making in your smart contract. Can you even see why it's important that you write test? If we didn't write this test, now me looking at this contract, I didn't know we didn't add check deadline to see whether a person can still contribute afterwards, after the deadline. So it's important that you just have to make decisions when writing your code. But let's just add it. Let's add it. Let's add it. And then we want to also check. We want to check. We want to check for claiming. Now, I think that's enough test for contribution. Let's also check for claim. So we want to test to claim fund. Test to claim if successful. Okay, test to claim. Check if successful. Okay, what other one can we think of? Another one we should think of is a person trying to claim early. Test to claim early. Okay, what else can we check for? Um, okay, test to claim funds without goal reached. Test to claim funds without goals reached. See how plenty our test is. How many functions do we have in our contract? We have 1, 2, 3, 4, 5, 6, 7, 8. Now, see how many tests we have written out that we want to test. It's definitely going to be more than our contract. The test functions will definitely be more than our contract. This is how important test is. So we are going to test to check. Now, another trick you can apply when writing tests. Now, for people that write Solidity or that have written other smart contracts, it's easy for you to actually not construct your test. I mean, one of the pointers you think of is your require statement, your assert. Well, you check for it. You check that all of this is working well. For example, this assert, this test to claim early. This is the test. No, we are working on claim. Okay, this is the test. So check deadline. We are writing a test to claim early. Amount raised. We are writing to test if the person can literally. It should return us this error. Campaign goal not reached. Right? Then another one is assert campaign claimed. Funds already claimed. Can you see? So all of that. Now, there is something we did not do. We did not add some certain things to our error. For example, while writing our error, there are certain things we wanted to check, but we did not add it to it. And so now that I'm even talking about this error, it reminded me. For example, we are meant to add things like this. Meant to add a street to it. Meant to add this RP trait U32. This literally is going to help with this numbering that was given. Then other errors that we are expecting, we would literally be passing in those errors for our test. So those errors, we can number them here. and name them, in fact. So we are going to name them. We have campaign not found, not found. Let's have it as number 2. Let me look at other ones. This gets campaigns. Another one is deadline. Spoke about deadline. Let's include deadline. So we're going to include deadline exceeded. We are going to see how important what I'm doing is when we start writing the test. Also, for goal not reached. We spoke about goal not reached. This one, goal not reached. Let's go back to it and let's include that goal not reached. Going to make that 4. Then another one is someone trying to deposit invalid amount. I think we spoke about invalid amount. Yeah. Contribution amount must be positive. Yeah, invalid amount. So let's add that too. So we're going to add invalid what amount. We're going to make that number 5. Then which other one again? Let's look. We have a require authorization. So let's add authorizations error. Someone trying to call what is not meant to call. So unauthorized access. Let's make that number 6. Is there any other one? Is there any other one? Let's look at it. Let's look at it. Okay, unclaimed funds. Okay, these funds. Funds already claimed. We didn't include that. Okay, so let's add that in our error. Funds already claimed. Then, okay, let's continue. Then let's have campaign. Is there another one? Okay, we have this one. Campaign is still active. I don't think we've added that. Have we added it? Campaign not found. Okay, we have campaign not still active. So let's make that here. Campaign still active. Let's make that. Let's make that number 7. And make this one number 8. Then next, which other one? Do we have contribution not found? Contribution not found. Let's see. Okay, yeah, I know we had something like that. No contribution available. Yeah. So if an individual person is trying to withdraw that, is trying to get a refund when he never contributed, or probably he has already contributed and he has gotten his refund and he wants to try to get refund again, he should return no contribution available. So let's add that one too. No contribution found. So all of these errors, we are going to be trying to expect them inside of our tests. And we should be looking forward to it. So at this point, is there anyone that have any question before we dive back into our test? Anyone with any question? Okay, Intiro. You can unmute and speak, please. I cannot hear interior.
Hello?
Okay, I can hear you now.
Okay, nice. Um, yeah, so those errors are for the negative cases, but again, coming from like Solidity stuff, what about like events and logs and stuff like that?
So notice that we didn't even log any events in this whole contract. We did not log any events. We wrote our contract plain. There was no log of any event. I think the next contract we are writing, we should include events and then test for those events too, right?
Right, perfect. So it's possible. Um, and then what happens when asserts don't pass? Is the transaction reverted?
The transaction is reverted basically.
Okay,
It just work. You can think of it just like your Solidity smart contract. And that's why we are writing the test for it. So it's definitely going to revert and give us the error message.
perfect, perfect. Um, and then maybe I missed that session, but could you go into how require auth works a bit?
Oh, so you can think of require auth as more like thinking when you in Solidity, you can think of it as access control, or in fact, like the owner only owners. So you can think of it as only owner. So inside of it, it's literally going to create a situation whereby only the person who created the contract can call that function. So only certain individuals can call that function. So the require auth is just acting as access control to the contract basically. So only certain people that are required to call that function can basically call the function. Yeah, as you can see.
Yeah, but to me, it looked like you're using it for like contributors as well.
Yes, yes. And we are going
So
to the test is going to I get you for yeah, right?
yeah,
So the test we are going to check if certain people are allowed. In fact, that's going to be part of the test. Certain people are allowed to contribute. I don't know if you get that. So if certain people are not allowed to contribute, then they would not be able to contribute.
okay. So it's like a list of addresses that are allowed,
Yes. Yeah.
but again, my question is like the
It's
extent
a
of the
crowdfunding
access.
and everybody should be able to contribute, right?
Yeah, but one would presume that maybe, for example, only the owner can uh, do certain functions. Maybe I'm not sure if require auth is something that is configurable or it's something that is like um, an operation on the SCP on Stella itself.
I don't get what you're trying to
Okay,
say.
so when I say that, what I mean is that it has only one function, which means that only one address is the owner of this contract. But then
Yes.
the way it's being used here, it
Oh,
shows
oh,
that it's
oh,
a
oh,
list
oh.
of multiple addresses that have access to contribute to the contributions.
Yes. So now you're trying to say that since the contract probably have been able to track only the person who created the contract, right? Then you
Yes.
want to believe that only that address is probably going to have the opportunity as the only owner kind of power when we talk about Solidity. And that would be like the only address that is being tracked to, to perform certain authorizations in the contract. But when you think of authorizations in Soroban, it's a little different from that in Solidity. Now, I'm going to continue with the test, and during the test, we would see how we authorized a person to participate, to call a particular function, and then you would then compare it to how, because obviously I know for Solidity, imagine access control is being used. Then for the access control, you have to grant all of the different roles to those that are giving the access control roles. And yeah, we're going to see how that is being done here. Is that fine?
Perfect. Thanks.
Okay, then. So, oh, sorry, I don't know. Okay, okay. So let's go back to our tests. And obviously, the first thing we want to do is the setup. Now, for those that are familiar with Foundry, setup is usually the first thing you want to do. And setup literally helps you initialize all the things you want to initialize now without you having to repeat creating contract or creating and doing different things. So setup is literally the way to go. Setup is literally the way to go. We're going to create a function and call it setup env. So for the setup env, we're going to have env, we're going to have address. So it's meant to return the env, it's meant to return certain addresses. We're going to say all of that. So this first address would be the creator address. Then this second address would be the contributor address. So we're going to see uh, address. And then we would have crowdfunding client. So we have crowdfunding client. It's going to be, we use static for that. Static. And yeah. So yeah, the things. Let's use cargo FMT. Let's try to format it. Okay. It didn't format it the way I thought it should. Okay. So the first thing we want to create is definitely the environment. So we create the env. We already know how the test works. So we have the default here. And then next, we have the creator. For the creator, we're going to generate an address for the creator, just like you would use generate address inside of Foundry. We're going to generate an address for the creator. So we use generate and we pass in the env. Yeah. Then next thing we want to do is for the contributor. We are going to generate an address for the contributor to generate. Then for the token, we're going to generate. And here we have env. And yeah. So we're going to create the clients. So for the client, we have the crowdfunding client, new, and We're going to take in EMV and the contract address. So for this contract address, let's try to create the contract address here. Let's contract address equals, for that we would have EMV. Let's just have EMV dot register. EMV dot register contract. I think we already established that dot register contract does not work. Or does it? Oh, it's deprecated. I think we agreed on that from last time. This should have crowdfunding. Okay, so this is deprecated, but let's see. We have this here. If we have this as borrowed, then this would stop the issue. This is deprecated, if you can remember. Yep, deprecated. So it says use register. And last time when we were writing our test, we used register. So when we used register, I think we had the contract in front. And what did we have at the back of register? We have the argument. What did we use as our argument then? What did we use as our argument then? Should we use none? Did we use none then? None. Did we use none? Okay. Okay. Let's use some 0. So what did it take? We are not passing in anything here. So what is it accepting? Why is it accepting? Things have changed. It's still rejecting it. Okay, let's pause for that. Let's just try to initialize the clients, and clients dot initialize, and we would have the token initialized, and then it would return EMV, the creator, the contributor address, and then the client. Okay, but now let's get back to this. So what did we use instead? Did we use an okay? So what would it have wanted us to use? Okay, let's see. It uses a trait. Okay, what did we implement from last class? Just for us to avoid this stress, I would rather prefer us to use this. It's deprecated, but it still definitely works. Sometimes it's deprecated, but it's definitely still works. But you know what? Let's use what actually works. So what we did last was, I think it was here, right? Okay. Okay, let me just open this. Because I know we tested it and it's worked. So what did we do then? We used, this is interesting. Here's what we did last time. So it did not want, it just wanted something empty. Can't believe I forgot that. Okay, interesting. You just have to stick. New implementations definitely have to stick. Okay, with this, we have created a setup environment, and we can basically keep calling this setup environment whenever we need it for whatever we need. So the first thing we want to do is our first test. Well, give me a second. Your hands are up, Intiro. Do you still have questions? Intiro, do you still have questions?
No, no, I'm good. Thanks. Sorry.
Okay. I thought someone would have reminded me of this because I know when we were writing our test the other time, we saw that it was deprecated and then we had to use this. And then I thought someone would remind me of this, but no one did. Okay. Things change so fast when it comes to a language. Now, the next thing we are going to do now is we are going to test our. Are we even done with writing all the tests we need? We said we wanted to test the claim funds. What else apart from funds? Claim funds. We still have refund. We should test for refunds too. So let's add test what? Test if refund is successful. Then we also want to test if, let me see. We want to test if there was no contribution. Let's test for this. Someone trying to get a refund when he never contributed. Test for no contribution. Then next, we want to also test for all the campaign. Let's just test for all campaign. Test to get all campaign. Test to get all campaigns. Okay. Wow, our time is fast spent. I think we should stop here. I was meant to send something to Intiro. I'm always forgetting. So let me send it now. So we are going to stop here. Our time is fast spent. Are there any questions based on what we have discussed today? I know we keep on moving and things change literally. Things change literally when it comes to programming languages, and don't be surprised when you see some changes. Just keep updating yourself. Just keep updating yourself. Some things are deprecated and no longer in use. So just keep updating yourself. But
Yeah, I have a question.
yeah,
Earlier, you mentioned Foundry, so I was wondering if there's a similar environment here as well for testing.
I didn't get that.
Earlier, you had mentioned, like when we were setting up the tests, you
Yeah.
mentioned Foundry. So
Yeah,
I'm wondering
I
if,
mentioned that just like Foundry, you create a setup function for your test. The way
okay,
you create it, that's what I said,
yeah,
that I was going to create a setup for my AMV.
perfect.
And for your question, you know, Foundry, it's these people that that are literally working with Foundry. Can you remind me the name of the team behind Foundry? Uh, Foundry was written with Rust too. Of I don't know why I can't just remember the name of the team behind Foundry. So it's just like
I'm
thinking
thinking
of
of Paradigm, but I'm not
a
sure.
paradigm. Yeah, yeah. So you can just think of the fact that, okay, a team created a tool for this language solidity. And right now, you yourself can even create a tool for testing it. But the test is literally in the same language, Rust, which is definitely fast. And so there is really, really no need to create another tool for it again, because all of these tests we are trying to do is literally already in Rust. And
Yeah,
so I don't know what other language. Foundry was created because it's easier to test solidity in solidity. You get, using something like ADAT, you now have to write your test in TypeScript. It becomes, it makes it slower and more hassles. Foundry comes with so many cheats and all of that. So
yeah.
that's for this case, it's already written in Rust. It's easy to test in Rust. So I'd
Why
really
I was asking that is like for a local test net and like trying many accounts and interactions like with
May,
the front end as well.
may, continue, please. Continue, please.
Yeah, when you have like a local test net, you're able to do like more kind of weird and funny tests, like when you're
Okay.
interacting with the front end and all of this. So that's why I'm asking if there's a similar environment to like Hard Hat and Foundry where you can do all those kind of tests, or are we just going to be testing like
Now
regular?
I get what you're trying to talk about. Testing different scenarios. I think all of those testing of different scenarios, we literally have opportunities to do that right here. Now, ADAT and Foundry environments will give us the ability to warp time, those to time warp, for example. Now, notice that here we are setting a time for our contract. We definitely, to write that test, we definitely need to kind of time warp the time. And we already mentioned that this ENV gives us access to some certain test suites. So it gives us the test state. So where we can perform different operations that we would probably want to do on the mainnet. I don't know if you get what I'm trying to say. So what other things do you think Adas Foundry would give us the opportunity to do that we cannot do here? If you talk of fuzzing, Rust already have the ability to do that, the language itself. So do you think there are any other things you would want that is not available for you?
Yeah, maybe if my contract has something to do with the specific block and I'm calling for details about a specific block and I want to.
Exactly. We have that here. Notice that at this point, we were talking about, let me look for it. We were talking about the timestamp. Now, the timestamp inside of that environment, we could also get the ledger. That's the block. Let's go back to deadline and okay, let's go back to ledger. Under ledger, we have certain things like the timestamp and the block. Let me see. Inside of here, we should have, here it is. We have the max life until the ledger. We can check that. We can check the sequence number. This is like the block number. We can check that. There are so many things we can literally check. So we can do the same thing. I mean, if the situation or scenario comes for what we want to do, unless what you want to talk about then would probably be main networking, you get. So if you talk of main networking, then that kind of situation or scenario is what is kind of different. I don't think the Soroban has the opportunity for that. I'm not sure. I'm not sure.
If you're to estimate, how big do you think the mainnet is?
What?
How big do you think it is, the mainnet? if I was to like
That's for the clients.
the whole chain.
Yes, yes, I get you. That's the whole client. You're talking of the
Yeah,
protocol itself.
yeah.
Ah, I do. How big is it right now? Unless we have to contact Google. Hmm, Is the yeah? Do they even have that here? This is the network data. Okay, we have for let's have the overview. How big? So we don't use this to take our time. I really don't have idea on that. I really
Okay.
don't have idea on
I'll,
that.
I'll try. I'll try and find it myself. Thanks.
Do you want to start running a node? Do you
No,
want
I
to
was
be
just curious about that, and how the sharding works and all of this. It should be smaller
oh,
theoretically, but
definitely. You remember one of the things we were talking about in our previous class was the fact that we have temporary storage. And for something like that, definitely it would be smaller than for Solidity. And apart from that, what is being pushed to the ledger is WASM bytecode. And definitely WASM bytecode is smaller than uh, uh, the bytecode that is being created for Solidity. It's actually smaller. So yeah.
yeah, thanks.
Thank you so much, Intiro, for your question. It was engaging. So we'll stop the lectures here. But Intiro, if I may ask you, have you been able to complete your own questions for the class practices?
No, not yet.
Okay. So which one have you done, though?
I haven't completed any of them, to be
Okay.
honest. Yeah,
Okay, okay, no problem, no problem. So yeah, I'll hand over the class back to IJ and we can proceed.